A question?
Usually you do 70-30 or 80-20 the test and train data set. Why did you do 9?
It was, because we don't have so much data. In the database, we had 5 files. I'm talking about mega. This is what the main reason.
Thank you. Okay, so we have the dialysis prediction project next. We have the 3 last projects, so maybe we could do a little exercise. We're all stand up because I see your faces of tiredness of Friday night. So if you bear with me, stand up right now. Then you can perhaps just a very simple exercise, like you can stretch, like the weekend's coming over. Just pretend that we're not in a corporate office. Just give it your best, like some stretches. And then pick a person and tell them why you're here and hear what him or her has to tell you about why they're here.
Yeah, because we are alumni, right? Yeah, we have reservations here in this second area. Nice. Good. Keep studying as well.
Okay,
yeah,
perfect.
I'm focusing a little bit more on other areas of blood science to try to fill the gaps around.
Okay. Clap once. If you can hear me, clap 2 times. If you can hear me, clap 3 times. Okay, good. It's just a quick trick to grab your attention. Maybe another thing is, in this kind of events, you never know who's sitting right next to you. So perhaps you could share what you currently do and what you aim to do in the next year with the same person that you interacted or with another one, and then we'll sit down and begin there.
It's just because I think it's happening and I don't speak to me.
Okay, perfect. Again, if you can hear me, please clap once. If you can hear me, clap 2 times. And if you can really hear me, clap 3 times. Okay, so there's this very brief break. We have 3 presentations more to go, and then you have all the time of the world. I would really ask you to sit down again. I know I created this chaos, but I'm trying to get back onto the dispersion and the entropy. And now give the floor to one of the last projects, which is about dialysis prediction. I'm not going to tell you anything more besides the fact that they work with some data from the MIT, and they obtained some really interesting results because you placed 3rd on the competition, so I'll give you the mic.
Okay. Well, good afternoon, everyone. And let me present our project that we call Dialysis Spread. And in this project, we basically applied machine learning for we applied machine learning to critical patients' data to make some predictions. Well, to focus on the big data set that we had, we addressed the question of dialysis needs among acute kidney injury patients. Here, I present some details of why this problem has some importance, and as you can see, these are the cost of current ACI therapies in the US, and dialysis plays a key role among this financial and human cost. and it can involve up to 50% of the cost of these therapies. So we thought it was something that can be important. there was this slide like so here I present our solution that is based on forecasting dialysis needs among these patients so that we can have an early diagnosis of these needs, and it can lead to a cost reduction of the treatment, of the diagnosis, and of course a cost reduction of the hospital resources management.
Okay, so once we have presented the problem, this is the workflow we have followed to address it. We have started with a huge database from the critical care unit. So the thing is that this was huge, so we had to use Google Cloud methods like storage to manage. So the next step was to create a derived database with the variables we wanted, and then extract the patient data with AKI that went to dialysis or not dialysis. Then we explored the dataset and prepared it for the machine learning algorithms. We used binary classification models, and among of them were KNN, NetBias, logistic regression, random forest, or support vector machines. We did some measures in the performance and tuned some parameters so we could improve the accuracy. So these are the results. The best model was KNN, and you can see that the accuracy is 0.87 with area under the curve of 0.62. And the most relevant results to predict the patients were like how many time they have spent it in the intense care unit, the urine output, the maximum level of creatinine, and so on.
You have to switch to the left?
Not yet. Okay, one second. So we decided to create a web app to help doctors predict if the patient will need dialysis or not. This is our web app. You can scan this QR code and try it on your mobile phones, and we will do a quick demo. Can you click the link? And you can input these values. It's not yet. So we predicted that this patient will eventually need dialysis. Can we go back to the presentation? Thank you. So some problems that we had while doing this project, first of all, was the amount of that data. We had too much data to process on our local computer, so we had to use Google Cloud. We didn't know how to use Google Cloud, so we had to learn first. Then another problem we had was the quality of the data. We had an unbalanced data set, and we had to address a lot of data pre-processing. And the last one was the lack of medical knowledge for us, because we are not doctors, any of us. And maybe some variable we didn't know actually what it really means, and maybe there is some medical mistake in there. So we have to talk with some doctor and make sure that everything we did was right. So finally, for the future, we are planning to release a paper with these findings, which of course we need the revision of a doctor. We are planning to apply to a Google grant for social good projects, and we want to release this application to all the doctors around the world so they can improve the health of their patients. And finally, this is our amazing team. Thank you. Anyone have a question?
No, we don't get anyone.
Did you consider the confusion matrix results? Because, for example, if you predict that a patient does not need dialysis and then in the end he needs, well, it's going to be a huge mistake. Or otherwise, if you say that, okay, he needs, but in reality he doesn't need, did you count somehow the economical situation, like for these errors? Did you increase their value in the model? Because there should be another metric apart from accuracy, I think. Confusion metrics regarding true negatives and false positives. I don't know if I explained myself.
That's the point in this kind of problems, because I work in the hospital and I deal with these kind of problems every day, is that it depends in the problem if you prefer to have false negative or false positive. I mean, it's better to have someone predicted as it needs dialysis, or in the other way, it's better to make bad predictions, but in the other way, like he doesn't need dialysis, but it really needs. We are not doctors, so this is a little bit hard for us, but we are planning to speak with the doctor, because this is work we started in a datathon, so we had like the support of 2 doctors, and we are planning like to speak with them so we can adjust this thing. But I mean, this is only something like to give an idea to the doctors. This is not like the real truth. I mean, they have these tools to improve their diagnosis or the thing they decide, but it's not. I mean, if this says this patient doesn't need, that's not mean that doesn't mean that he's not going to have it or she's not going to have it. So it's better perhaps even saying yes or no. You can give like a score to say, oh, this is going to need, but with I don't know, with a probability of 0.7. So you can like have an idea, like change the care of the patient depending on. But yes, it's a lot of work to do with this. I mean, this is like something good and promising, but we will keep working on this. Thank you. Thank you.
Given that talk, you would basically tailor it to accept the false positives so that they have to do a dialysis test and just deny every single false negative. You just have to set a higher threshold. But I think this highlights a very interesting application of machine learning, which is people that are not doctors are able to achieve results that beat human doctors in some cases. Like, for example, Stanford with cancer prediction is able to detect lung cancer with 99.8 accuracy, or the world's best doctors only get 98%. So I think, again, this is a really interesting project. I hope you put it through, and of course, they give you the Google grant. But this is another example of why machine learning or AI could be applied to your field. Because if you already have that knowledge and you put AI on top of it, you really can push it beyond the normal standards. So for the next project, thank you. I'm going to give you a nice round of applause. For the next project, I'm slightly biased, but this is one of my favorite projects. Basically, because they've taken a problem that happens consistently in the Mediterranean and that we choose to ignore, that we have become insensitized to it. And it was inspired by Proactive Open Arms, and I don't want to spoil anything else, so I'll just give the mic to Miguel and let him tell you more.
Okay, thank you, Jan. Well, first of all, excuse Luis and Santi because they were caught because this flu epidemic that we have now this week. Jan is there. So, okay, this project is super cool to work with because you are combining space technology, satellites, plus deep learning, artificial intelligence, I think it can be cooler. Well, you can put some blockchain somewhere. But okay, I think it's difficult to read, okay? And the main thing is that it's focused on saving lives of people who are traveling the Mediterranean in bad conditions, trying to get a better life. So there's no. The first question we have to do is what is the life of, what is the value of a life? Indeed it has a price. If you can measure that, it goes from $100 to millions. But that is the range, and it's serious about that. And that's why we wanted to do this project, because there are some lives that, as you all know, are apparently worth less than others. Hundreds of thousands of people who have crossed the Mediterranean during the last years, particularly due to the Syrian refugee crisis and other reasons. But it's a real problem. We have a lot of governments working on that, and they are very good. They are really good job saving people. And then we have some civil organizations like Proactiva Operats here in Barcelona that are putting even more effort, more commitment sometimes to bring these people safe home, whatever it is home. This is a crisis, but that is what happens in the sea. You have a small boat. Well, it's not so small indeed, right? But you have a relatively small boat that is adrift on the Mediterranean Sea, and you have a lot of people. Indeed, this is a lot of people who are crossing from Libya. This is the most deadly route right now when crossing the Mediterranean Sea in this way. Okay, and of course, most of the migrants come to Europe not by these conditions, but by the airports or trains or by car or whatever. So we were thinking, how can we approach this problem, this issue with artificial intelligence? And well, we want to choose a potential field of application. In this case was the coast of Libya, because there is a big problem there. And then we have to take into consideration some variables. We have a constellation of satellites from the European Space Agency with public data. Everybody can access that. The Sentinel constellation is one of them. And we focus on the Sentinel-2. That is one of the satellites that has a good revisit in the latitudes we were focusing on. Within 2-3 days of revisit, we had a very good resolution per pixel for a public access data set. In this case, about 10 meters per pixel. Yes, that's very good indeed. The assumption we made to find out people in the sea is that the infrared emissions, infrared radiation that has a human body, you have a lot of people all together in a small boat. So that's a lot of radiation emitting. We estimated between 3 to 50 watts. So we can find, in case you have the image, you can find it, you can recognize that. So we went to work with the deep learning model. We implemented a convolutional neural network because it's the tool of choice for this kind of work. We first tried a BGG, afterwards we tried a ResNet, and finally we got the best result with a UNet. A UNet is a very good example of what the promise of deep learning and artificial intelligence is doing, because the UNet was released at the end of 2015 as a biomedical data convolutional network. And afterwards, with transfer learning and trying with other datasets, it was demonstrated that it has a very good better results than other convolutional CNNs that were not thinking to that kind of data. So for this work, we find out that the dataset, the UNet model was the best one. We got the data to build a custom dataset, because at the end of the day, what we built was a proof of concept, not a big prototype, because the problems and the challenges that we will comment further. But we use public data that we have in the course of in the Mediterranean coast in Barcelona and Tarragona. We have a lot of small words with it's called the RC or AGI. I don't remember the acronym correctly, but is this transmitter that is constantly transmitting the ID of the bot and the characteristics of the bot. So we train the model with that, with the data, with recognized small words. We proved that was able to that. We got the data from the Copernicus web access, and we tried and we demonstrated that it was feasible. It was feasible to find this kind of significant results. Just to print out, we have our access was a public access Sentinel-2, 1 meter, 1 pixel is about. Of course, there are much higher resolutions and better satellites and better imagery that is reserved for commercial purposes on one hand, and finally for military and defense purposes. That is one example of the sample of the pixels in the sea of a small ship with frontiers, it's military, defense, and the Sentinel-2. But still, using deep learning and convolutional neural network like UNet, we were able to get significant results. In this case, results means lives that can be saved. So for the implementation, some details about that. We trained the model in 16 by 16 pixels. The resolution implemented for higher resolution, but afterwards we arrived to a UNet. We need to customize the number of key. Also, the purpose of the vision we had is to kind of implement a mini Frontex. Frontex is the system to protect and defend the frontiers of the European Union. So it kind of mini humanitarian Frontex. But still we have a lot of work to do, and we need a lot of more resources. Also more satellite imagery resources, because the revisit is 2-3 days. But for our use case, is not enough. But we can manage that. I put in more data sources like radar, also more bandwidth, and of course other satellite constellations that can be combined to improve the revisit time. And we don't want to finish this without pointing out the dark side of all this, because everything we talk about, you know, with public information, with public access, things that you can do from your home, with your laptop, you connect to Google Cloud or wherever, and you do that. Well, this can be it's the same kind of approach that you use for weaponry, for artificial intelligence weapons, and well, it's some food for thought that what can do a weapon with this kind of technology, much better resources, much better resolution, you know, up to 1 meter per pixel, I think it is the state of the art right now. A deep learning model that predicts, that prescribes, like Amazon, that's at the end of the day it's the same, or even can choose the targets for weapons. So I think it's something that we have to act now before it's too late, because later we will not be able to do that, anything about that. So that's all.
I hope nobody got any kind of bad ideas with this, but I think there is a really interesting thought that needs to be highlighted, and is that this is the public data from the satellites. The European Union has access to 1 meter per pixel great technology, and the problem that we have right now is that they're not advertising it, but they are actively choosing not to use it. They're just not scanning so that they can say, you know, once it reaches the Italian coast, if they make it here, then it becomes our problem. Otherwise, good luck, have a fun trip at the sea. So I think this is, seriously, like this is a huge problem, which I think that with data can highlight that. With data, you're able to build a platform and say, ask your local representative and tell them, you know, there's a boat that's crossing right now the landing, it's gonna reach here in 2 days. Are you going to send a ship to intercept it, or are you going to ignore it and pretend to care when it gets to shore? So I think it's one of the powerful tools and implications of these kind of technologies, and Does anybody have any other kind of thoughts? Yeah,
No,
sure,
no, it's fine. So, how do you differentiate between the signal or the image between a normal small boat that some people are using just to go out of the coast and come back for a pleasure trip, and a boat with immigrants?
You can use some patterns. Indeed, unfortunately, it's easier to detect a small boat full of migrants than a pleasure boat if you are on a cruise in the Mediterranean. First of all, we are focusing on the coast of Libya, so very few pleasure cruises there. But even in the case, it's different tradition. So we have to train more, we have to experiment more, we have to build more things on that. But it's basically with patterns and probabilities. You have, at the end of the day, you put a threshold somewhere and decide what is. Another thing that is important is that to check if it's a small boat that is adrift, that is going, people is going to die in 24, 48, 72 hours, or it's just a small boat that is traveling. So that's also patterns. I don't know if it's what's okay. Yeah, the broad biases thing is very valuable here because most of the work here and to find out the insights from that. That's went to Kaggle to find out some of the competitions that are there about ship recognition, about Amazonas satellite imagery, and also we use the FastEye library. That is the one that we are using in the Saturday's courses. Indeed, that opens a lot of knowledge and how to do things. Okay.
Thanks.
Thank you. Thank you very much. Also, to answer that, I think you could basically benchmark the legal ships that you know that are crossing and that are approved to go through one path versus the ones that are not. And therefore, any illegal ship you want it intercepted, one purpose for saving lives, and the other could be if they're doing illegal fishing and so on and so forth. So we have the last project from Martin, and I'm really excited because I've been pushing him to. There, dang it. Do you have the? I suck. So that's my problem. That's one of the live problems, but we can fix it hopefully in 2 minutes because you sent me the link of the project and I can forward it to Manuel. Or to Theodore. Give me 1 second. I'm gonna hold the mic, or give it to Alex. This is an amazing entertainer. Give us some jokes.
I don't have any jokes.
Give us some
I seriously don't know what to say. Okay. You want to talk?
Well, since we have been talking about obsessive thoughts in the beginning, one of the things I sometimes wonder about is, well, you had the pyramids and you had all the workers around, like seeing this thing, like the sort of physical thing, but did they really think about what kind of implication this would have on the long run? And this is something I think about when it comes to astronomy, because the field is absolutely booming, because there's new technology, there is this huge amount of projects. One thing which drives this is Moore's law. We have CCD detectors, which is coming. And one of the projects I'm going to talk about is the LSST telescope. So the LSST telescope is like the next generation of optical telescopes. It has been in preparation for a long while, like it started planning around 2010, got funded in like the fiscal year of 2014, and then we start like science, like full science operation in 2023. And for 10 years, they're going to each night take off the sky. It's like this has this monstrous telescope, like 8.4 meters, for a survey telescope that is quite large. Like they have like custom-made camera from some of the best lab in the world, putting this together. And this will produce like 20 terabytes of data each night. There are larger experiments, but this is quite a ramp up from other astronomical experiments. And in total, we're talking about they will have like 100 petabytes of storage need for the whole experiment.
I have a question. What's the main challenge in your field right now? Where's the field going and why?
I mean, it really depends who you're asking. So my field is extragalactic astronomy. So we're doing large galaxy surveys, like taking pictures of the night sky.
Solving light.
You can answer later if you want.
I will just answer. So we take pictures of the night sky. We detect where there are galaxies, and from that we produce huge galaxy catalogs to do statistics with them. And what I'm mostly interested in is like using that to probe dark energy and dark matter, because how this distribution looks over time of the universe will tell you something about the content of the universe itself. So machine for measuring dark energy and dark matter. There are other people that are more interested in other things, because this is going to take pictures like every 15 seconds, because it has this huge mirror. It can afford taking pictures very rapidly and still be able to have enough light. And because mirror, because they're all the time on the telescope, they're just going to scan the whole night sky every night or every few nights. And one of the things this opens up is that they will see objects which are changing, like variable objects. So this project, together with my collaborator, is going to look at variable time series from this telescope. So this is simulated data in 6 different bands. It will get 37 billion stars and galaxies, and I give some of the data before. So here I show some of the data. So of course the telescope is not fully constructed yet, like it's getting there. So this is simulations which I use for preparing for what they're going to do with the data when it comes. It was part of a Kaggle challenge, and it gives you 7,800 objects and 500,000 test objects. So it's a very small training sample, which is one of the nasty things in astronomy, that we have lots of data, but very often there are few labeled objects, because following up these objects are expensive, because then you need other large telescopes with fibers. This is just an example of one actually quite simple object, where you have as a function of light the amount of light in different filters. And you see here that there is something happening here in a few of the bands, which is quite easy to detect. I'm going to go very light on this. I have to do some pre-processing. And if anyone needs to do pre-processing in Python out of core, out of memory and with multiple cores, you should have a look at that. So I did more fancy things, and I'm going to skip it by now. But one example of architecture, which is coded up in PyTorch, do some feature engineering, get like about 150 features from this time series, because irregular time series are very nasty. This is what I learned this semester. So coded up some network architecture here in PyTorch, and this is actually code that works. train it. This one in particular gave okay results, 73% accuracy. This is not the metric that we were tested on because it's quite a lot of imbalance between the classes. And I have to say that some classes are much more tricky than others. Like the one you saw was simple, but you also, in some cases, where you have extremely rapid oscillations where you don't pick up a good eye. So to conclude, well, LSD will be important for dark energy, for dark matter, but also the transients we're seeing there. Dusk is very nice. Even if I have access to a Spark cluster, I don't bother to use it because I can use this on a 32 gigabyte machine, and it still works. And irregular sparse time series are quite nasty because they did these observations and they have like seasons and how to deal with that. Well, you're not putting the you don't have the same time interval, made a problem quite difficult. And last, well, I guess it's going to be another edition of AI Saturday, so I will recommend you to join. And some people have talked about, well, being hired for doing kind of neural networks and so on might be tricky. It's another way of seeing it. If you learn it in this company, you might be the one that sucked the least at neural networks and the one that everyone asked about if it comes to neural networks. So, any questions?
Come on. Otherwise, I'm just going to throw it in the air. Okay, I asked one. You are obviously, well, you're scanning the whole space. So is there some kind of so huge memory, like it's taking so many gigabytes and gigabytes that you have to throw some data even at the beginning, or you are able to save all of those images and then later store it? Sometimes I feel like we have a need for saving everything, but obviously we cannot store the spectrum of the whole space no matter how many terabytes there are.
Yeah, I know that from reading some historical articles about the people dealing with the storage, that some of the founders thought, well, this would be impossible to store and they would have to throw it out. But then later on, they managed to actually store all of it. And I have to say that most of the storage is not for the raw data, but you have to do image reduction, and you probably have to do it more than once.
Thank you. That's it. Thank you very much for coming to the demo day. This is the calendar for the next sessions that we're going to have for launching on February 2nd. If you're interested in AI, I definitely encourage you to come because I think it's going to be even more awesome now that we're launching at the same time with Madrid, Almeria, Tarragona, Guayaquil, Lima, and Quito. So we should have a nice community of people doing the faster AI. And also, before, if you want to sign up, there's a 30% coding discount that you can cash in here. But the highest thing that I wanted to highlight is I wanted to get all the people that have helped, all the facilitators to come up to stage so we can take a picture, because this would have never happened without you. So Hermes, I'm talking to you, and Sugar, I'm also talking to you. I know you guys are shy when you need to come up. Miguel, I don't know where you are. Albert, come up here, please, when you take a picture, because really what it is about 12 weekends where there's a set of people that are working nonstop to ensure, David, you don't feel identified, but you should come still. These are people that are working 12 weeks in a row to ensure that you have no friction in terms like the coffee is served, the event is arranged, and that you can focus on AI. And I would really like that you could give them a very nice warm round of applause. The fellows that finished the last batch, also please just come around here. Let's take a picture together, and then we can go on the networking and snacks, because I'm sure Vistaprint also wants to close the venue because it's very late and we're running on the stand. Thank you again for coming on a Friday night. I know it's not the usual. I think you have a special kind of attitude if you want to learn in this time of the day. So thank you as well to you for coming. Thank you so much. I think there are some beers in the fridge if you want that.
So, ¿tú qué opinas? ¿Cuál es la respuesta de la seguridad? ¿Cuál? La de... Tú predices el mercado, pero luego inviertes y la modifican tu bueno, si lo haces tú, pues no mucha información, deja de ser un... ¿Pero esa es tu respuesta o la mía? Vale, yo pregunto por tu opinión. ¿Tú qué crees? ¿Tú cómo responderías a esa pregunta?